All right. Good morning. Third period, thanks for your patience. We're going to make a video here that can be used in other places. Can everybody hear me from the back of the classroom? Give me a nod if you can hear me. Nod. Nod. Sounds good. Tyler, you good? Tyler, you playing a game? You want to make some notes? All right. Here in class, we're looking at a written document. I'm going to go ahead and put the date, today's date. Add that to the top and add your name. If I find one in the room, I'll put it in your folder. Okay. And the topic that we're going over is data analysis here. We've covered things like central tendency in the past, like how to describe the middle of the data, but this is another piece of data analysis. So I'm going to start zooming in so you guys can see me making notes up here. And I'll try to write kind of big so you guys can see. So just before Easter break, we found or calculated the summary statistics, mode, median, and mean for a variety of data sets, and they describe the central tendency of the data. Central tendency is just what you think of it. They describe the middle. So I'm adding that as a note. Central tendency describes the middle of the data. So we've seen data in lists, tables, and within figures. It's very important for your future that you're able to pull important information out from raw data. I'll try to zoom in even more so you guys can see. So you want to pull information out of raw data, not just describing the middle, but the new piece today. We will go beyond central tendency and we will talk about data variability. So data variability is a new definition for today. I'm going to add it here. Okay, the variability is a math description. It's mathematical. I'm just going to write math. Let's see how big my words are. Can you guys read it okay? It's a math description of how different data points are from the central tendency. So I'll stay zoomed in so people at home can see it, and then I will zoom out at the end. It's a math description of how different the data points are from the center of the data. And I'm going to give you a little bit more here. Okay, so variability is a math description of how different data points are from the center of the data and from other data points. There's not that many points on this paper to write things down. We'll be done soon. And here's the word that helps me. Like mode, I think of most. Median is for middle. When it comes to data variability, this is also known, AKA, as the spread in the data. The spread. So statistics is a discipline not used that much in high school, but it is a college degree. People get PhDs in statistics. And the variability is as important to understand as what an average is. How did the data points look when they were calculated into a mean? Okay, so it's a math description of how different data points are from the center of the data and from other data points, aka the spread in the data. That is the variability. It is the spread. Variability gives you a way to describe how much data varies and allows you to use statistics to compare your data to other sets, which we will do today. Okay, so we're going to need three main ways to describe variability. The first is probably something you've come across. Let me zoom back in. It's the range, and it's just a count. It is the numerical count, and you may use any sort of note on a test between the smallest and largest numbers in a data set. So the range is the numerical count between the smallest and the largest numbers. So if I would look on the warm-up problem, the range of my data go from 26 to 29. And that describes a version of how far they are spread apart. It is the spread. This next piece says interquartile range. That's probably the biggest word we will deal with. Interquartile range. Well, quartile, I think of 4 parts. The interquartile range breaks down your numbers, your data, into 4 parts. It is similar to range. It is similar. Only it describes the middle 50% of your data. So it doesn't give you a full picture of the range, like biggest to smallest. It tells you more about the middle 50%. I have a feeling I'm off the page there. Just zooming out. Interquartile range is similar to range, only it describes the middle 50% of data. And you'll see a graphic representation today that'll help you understand. And we're on the last one. Okay. This one says standard deviation. So deviation is another word for spread. Okay. The standard deviation tells you how clustered your data are. And we're going to have pictures of this too. How clustered your data are around the middle. So it's a mathematical number. And if once you get used to using the standard deviation, it'll tell you how much variation there is. It describes the clustering around the middle values. Okay. A small standard deviation, I'm just going to put SD and call this SD out in the margin. A small SD indicates tightly clustered data. The smaller the better. And there's a symbol for it. They use the Greek letter sigma. This is not something I made up to torture you. This is part of statistics worldwide and its language. They settled on Greek letters for a lot of purposes. The symbol for standard deviation is the Greek lowercase letter sigma here. Why do you care? because this is the way that data are reported, say, for like an election. So I could have an election result, and before it's official, they could say a candidate got 51%, but there's error that they're not sure about, described by the standard deviation, and they say, well, we're not totally sure yet because not every vote's been counted, so we're going to say it's 51% plus or minus 3%. And this is probably the most important thing I want you to get out of high school statistics, is that when somebody describes election data, say a candidate won by 51%, but the standard deviation is 3% either direction, that means this race is not yet over. And if you understand variability in data, you will have a better understanding than people around you. 51% plus or minus 3% means that the result in the end could be anywhere between 48 and 54, meaning this candidate could win or they could lose a majority vote. It's this plus or minus that you'll see on the news on election years that I want you guys to gain experience in while you're here in class. Okay. So I want to show you a couple here. I'm zooming in on these little bits of data here. Find the mean of these data and then name the range. Well, I calculated the mean for you. I want to give that to you. The mean is 50. If you add up 1, 2, 3, 4, 5, 6, 7, 8, and add up all these numbers and divide by 8, it comes to 50. But the range is a numerical count from smallest to largest. So why don't you guys give it a crack? What is the range of these data? Oh, I have my headphones on. What was it? How many digits between the smallest and the largest value? 20. Very good. The range of these data is 20. From smallest to largest. Now here's where understanding variability will help you find the mean of these data and name the range. Well, I did the same math down here. I added these up, and the mean, once again, came to 50. But what is the range of these data? What's the difference between the biggest value and the smallest value? 100 minus 0 equals 100. So here's an example of where the mean can come out identical. This one has an average of 50. This one has an average of 50. But it's about the variability in the data. Those are the two big differences here. This one, everything's between 40 and 60, so the range is 20. This one, if these were grades, they go between 0 and 100. So the range is the full spread of data from 0 to 100. You can see above that the mean values are the same, but the ranges are different. Now what? The difference is in the variability. Range is simple to calculate because it's the difference between two numbers. I guess I'll add this one up here. This was 60 minus 40 equals 20. That's how we calculated the range. Range is simpler to calculate. We will use spreadsheet computer programs to look at interquartile range and standard deviation. I have done these by hand. I think it's beyond the high school scope for the moment. So we will be using Google Sheets to do the math for us. I'm going to zoom out just a little bit. And that's everything that I added there. Folks on video, I'm going to hit pause on that while the room catches up to it, and I'll post a copy of these notes. And I hope you guys are doing well at home. We think about you here in class. Take care of yourselves.